I like riding a bike, and I also value my life, which is why this solid safety helmet is a must. Not bad looking either. A bicycle helmet is constructed of an exterior shell and an interior one of polystyrene foam designed to absorb shocks. Some designs for bicycle helmets are drawn by hand and with computer-aided graphics. The design has to take into account that it is not on a flat surface but on a rounded one. This creates optical deformities that have to be corrected. Fabrication begins with the exterior shell. This polymer sheet is heated in a heat former at a temperature of 65 degrees centigrade. The mold lifts the sheet and suctions it to fill all the cavities of the mold. This operation lasts about 1 minute and produces 4 shells. Then, when cooled down and hardened, the 4 shells are cut by hand. Ventilation openings are cut with a heated wire apparatus. These openings have been preformed during molding of the shell. The heated wire easily and neatly cuts the polymer. Next step, trimming the helmet to eliminate excess polymer. The circumference is manually cut using a router. The edges are then sanded to even them. It is also possible to cut the circumference of the shell with a heated wire. This operation takes more time but is more precise because of the resulting cleaner cut. Now they're going to fabricate the foam interior that will be placed inside the shell. It's made of polystyrene beads that will expand and bond together. This expander increases the volume of the granules that fall into it. Steam and an agitator let the polystyrene beads expand uniformly. The granules are now ready. The contents of this bin will be able to produce about 20 foam pieces, which will take shape on these molds. The press closes up for the 6 minutes that it takes to mold 4 foam pieces. The particles fuse with steam before being cooled with water. The foam is removed from the mold. Forms are produced for different helmets. Fusing of the particles has welded the granules to one another. Depending on the helmet model, openings have to be made with this heat iron to allow for installation of an air vent accessory. All that remains is to make the adjustment pads, cut with this press-powered stamper. The adjustment pads are held in with Velcro to allow easy adjustment of the helmet. This allows the cyclist to change the foam pads for greater comfort. Inserting the straps calls for good manual dexterity and takes only a minute. The shell and the polystyrene foam liner have to be joined. They're adjusted one inside the other, then solidly secured with adhesive tape. The helmet is now completed. And now it's ready for packaging. The safety helmets have to be certified, guaranteeing their safety, and conformity tests are done. At least one helmet in 500 will undergo this destructive test. Here it drops vertically onto a piece of steel. This facility can produce up to 4,000 helmets daily in hundreds of models and over 500 variations. Look around and you will find it. Used for everything from jet planes to cans, aluminum, light and strong, has earned its reputation as the wonder metal of the century. Aluminum, so widely used today and the world's most abundant metallic element, does not occur in a natural state. The most available source of aluminum is actually bauxite. Bauxite is mainly mined in tropical countries and carried by boat to the Quebec port of La Bay. The aluminum atom in bauxite is bonded to oxygen molecules. These bonds have to be broken by electrolysis to produce pure aluminum. Bauxite is carried by rail to the plant where it will be crushed. Then, through a chemical transformation called the Bayer process, alumina is extracted. This is then roasted in calciners to eliminate all moisture. This is alumina. It is transported by rail to the reduction facility. This plant has 432 pots in which a powerful electric current will be passed to produce electrolysis. An overhead crane dumps alumina into the pots. Then the electric current from the anode placed in the alumina passes through the alumina, which we see here right at the bottom of the pot. Via the process of reduction of the alumina at 950 degrees centigrade, the anodes lose volume and will have to be replaced. It's a continuous operation. Each anode has a lifespan of about 20 days. Spent anodes are recovered from the pot with this overhead crane and carried off to be recycled. They clean the aluminum rods, which will then be reused. Here we see the crust formed atop the anode. When the anodes are replaced, the accumulated impurities have to be recovered from the top of the pots. This is accomplished with these pincers. Then a new anode is inserted into the alumina and electrolysis continues. The electric current breaks the molecular bonds. The heavier aluminum collects at the bottom of the pot, while the oxygen bound to fluorine is released as a gas which is drawn off and treated. The liquefied aluminum remains at the bottom of the pot. It has to be recovered in this huge crucible with a tube. The tube is dipped into the bottom of the pot and a vacuum system draws the molten aluminum from the crucible. The aluminum is recovered in a short time. Air is vacuumed from the crucible by a flexible pipe held by an operator. The tube is finally withdrawn and the overhead crane dumps another quantity of alumina into the pot. Thus, the aluminum fabrication process continues uninterrupted. The crucibles filled with molten aluminum are transported to the casting house. Their contents are poured into holding furnaces which have a capacity of 60 tons. In these very hot furnaces, the molten aluminum is stored to await casting. Finally, casting begins. The aluminum is either semi-continuously vertically cast, producing ingots, sheets, or billets, or directly cast into semi-finished products. The cooling of aluminum pieces is accelerated by water sprays. The large rectangular ingots, which can weigh up to 25 tons, will head for hot rolling, eventually leading to fabrication of products such as aluminum foil. From 4 to 5 tons of bauxite have produced 2 tons of aluminum, which in turn produces 1 ton of aluminum. This particular plant produces 200,000 tons of aluminum annually, yet some other facilities can turn out as much as 400,000 tons.